Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 25 and today we are going to solve a problem based on greedy algorithms and the level of this question is going to be medium. The name of this question is Partition Labels. You will get this question link in description and you can also download this Excel sheet from description. Now without wasting much time, let's see our question. You can also read the question statement on LeetCode, but there the question statement is bit confusing. Therefore, I have written the question in the most simplest form here so that you can understand this easily. So the question says that you are given a string named as S and your task is to split this string into as many parts as possible such that each letter appears in only one part. So let's say we are having a string named as S, and if I just divide it into different parts, or you can say different substrings, okay? So let's say this is substring number 1, this is substring number 2, and this is substring number 3. Okay, so inside this substring, if I'm having a letter, let's say A, then this A, it should not be present inside my substring 2 and inside my substring 3. Similarly, inside my substring 3, if I'm having a letter, let's say Z, then this Z, it should not be present inside my substring 1 and substring 2. Okay. Similarly, inside this substring 2, if I'm having a letter, let's say E, then this E, it should not be present inside my substring 3 and substring 1. Okay. So if I'm having a letter in one substring, then that letter should not be present in other substrings. Okay. This is the question. And we have to split our string S into as many parts as possible, right? And we need to return the sizes of these parts as a vector or list of integers, right? So we just need to return the sizes of our substrings, okay? The size of this substring 1, the size of this substring 2, and the size of this substring 3. So I hope the question is clear, but still let me just give you some sample test cases so that you will understand this question in more depth. Let's take this particular test case to understand our question, right? So this is our string S, okay? This is our string S. So we need to divide this string S into different parts or into different substrings such that a letter which is present inside my part 1, it will not be present in the other parts. Okay. I can divide this string S into 3 parts. Okay. This is my part number 1. This is my part number 2. And this is my part number 3. Right. If you clearly see inside this part 1, I'm having a letter A. Right. And this A is only present inside my part 1. This letter A is not present inside my part 2 and it is also not present inside my part 3. Similarly, inside my part 1, I'm having one more letter B, okay? And this letter B is also present only inside my part 1. It is not present inside my part 2 and also not in my part 3, okay? Similarly, inside my part 2, I'm having a letter E and it is only present inside my part 2. It is neither present in part 1 nor in part 3. Similarly, inside my part 3, I'm having a letter J and this J is only present inside my part 1 and it is not present in the other 2 parts. Okay, so I hope you have understood the question. So we need to return the length of this path. Okay, so the length of my path 1 is 9, the length of my path 2 is 7 and the length of my path 3 is 8. Okay, so I will return a vector or a list containing these parts. Okay, you have to make sure that you are dividing the strings in the correct order, right? So the first part of the string will be this, right? And the second part of the string will be this. And the third part of the string will be this, okay? So after dividing our strings into different parts, if I combine all those parts, I should get my original string, okay? I hope you have understood the question now. So now let's try to think of how we can solve this problem. Let's take this particular test case to understand how we are going to solve this problem. So let's say initially I'm standing here at index number 0. So I have a variable I and it is pointing at index 0. So the character or the letter which is present at this index is A. So I need to make sure that I divide my string S into such a substring that this S, it should only be present inside that substring and this A should not be present inside the other substrings. Okay, and how we can do that? So probably I can think of what is the last index of A, right? or this A is appearing at the last time on which index. Here you can clearly see that this 8 is the last index of A. What does it mean? It means that this A is only appearing into this particular substring, okay? And this A is not appearing in the other part of my string. Or you can say that this A is only appearing into this substring, and it will not be present in any other substrings of this string S. So this is the intuition which we are going to use to solve this problem. So let's say initially I'm standing here at index 0 and the character which I found at this particular index is A. So what I'll do, I'll try to find out what is the last index of this character A. Here you can clearly see that this 8 is the last index of this character A. It means that our character A is not present outside of this particular substring, okay? But is this substring is our valid substring, or is this substring is one of our answers? The answer can be probably no. Why? Because we only have checked our condition for this particular character, right? We have only checked our condition for character A, but also we have to make sure that all the characters which are present inside this particular substring, they should also be only present in this substring, right? For example, if I'm having a B here, I need to make sure that this B is present only inside this particular part of my string. This B, it should not be present inside the other part of my string, okay? So I hope it is clear to you. So we can have one pointer or one variable J which will point at index number 1, okay? This J is nothing but I plus 1, right? So now I will check. If I'm standing here at index J, the character which I found was B. So I will see what is the last index of B. You can clearly see that the last index of B is 5, right? And this index 5 is coming, into this particular subpart, okay? It is coming inside this particular subpart. See, what I'm trying to say, from index number I, which is pointing at 0, up to index number last, okay? Let's say we are having one variable last, which is pointing at the last index, okay? So the last is pointing at 8. It means that all the characters which are present inside this particular 2 indexes, they should only be present inside these 2 indexes, right? For example, we are having a B, right? And the last index of this B is 5, right? And this 5, it is lesser than our last variable. The value of last is 8. So this 5 is lesser than 8. What does it mean? It means that the last occurrence of this B is also inside our substring, right? It is also inside our substring, which is ending at index number 8. It means that this B is also only coming inside this particular substring. It is not coming outside of this substring, okay? So now we will check for the next letter, right? So now I will increment my J. So now my J will come here at index number 2. So here at index number 2, the letter or the character which I have encountered is A. And what is the last occurrence of A? So the last occurrence of A is index number 8, okay? And we know that the index 8 is lesser than or equal to our last index, which is 8, okay? So you can say that the last occurrence of this A is also inside our this particular substring. It means that yes, this is also valid, right? So now what I'll do, I will increment the value of J. So now my J will point here at index number 3. When we are standing at index number 3, the letter which I encountered is B, okay? So I need to make sure that the last occurrence of this letter B, it should be less than my last variable, right? It should be lesser than this last variable which is pointing at 8. Or you can say that the last occurrence of this B, it should be inside this particular substring. So the last index of B is 5, right? And it is lesser than 8. It means that this letter B is only occurring inside this particular part of my string, okay? It is not occurring outside of this particular part, okay? It means that this is also valid. So now we need to move to the next indexes to check the other characters. So now let's say my J is pointing here at index number 4 and the letter which is present at index 4 is C. So I need to make sure that the last occurrence of this character C is inside our string. It is inside this particular substring. Okay. So the last occurrence of this C is 7. Okay. It is 7. And you can clearly see that this 7 is lesser than my 8. Okay. It means that the last occurrence of this C is also coming inside our part 1 or inside our substring 1. Okay. This is nothing but you can call it as your part 1. Okay. So now what we will do, we will move to the next index, right? We will move to the next index. So now we will move to index number 5, right? My J is pointing here at index 5. Again, we will do the same thing. We will check what is the last occurrence of this letter B. So the last occurrence of this letter B is index 5 itself. Okay. And you can clearly see that this 5 is lesser than 8. Okay. This 5 is lesser than 8. It means that this B is only occurring inside my part 1 or inside my substring 1. Similarly, I need to check this condition for all the other characters which are present inside my part 1. So now let's say my J is pointing here at index number 6 and the character which is present here is A, right? So what we'll do, we will check what is the last index of A. So the last index of A is 8. Okay. And you can clearly see that this 8 is lesser than or equal to my last variable. Okay. This 8 is equal to my last variable. What does it mean? It means that this A is also appearing only inside my part 1. Okay. It is not occurring outside of my part 1. Okay. So I need to check this condition for all the characters which are present inside my part 1. So now my variable J will go to the next index, which is index 7. So now my J is pointing here at index number 7. So we will again check which character is present here. So the character is C. Okay. So now we will check what is the last index of C. So the last index of C is 7. Okay. Here you can see that this is the last index of C. Now we will make sure that this 7, it should be lesser than or equal to our last variable, right? And inside our last variable, the value is 8. So here you can clearly see that this 7 is lesser than 8. What does it mean? It means that this particular letter C, it is appearing only inside my part 1, right? It is not appearing outside this part or outside of this substring. Okay. So now we will move to the next index, which is our last index itself. So we do not need to check our last index. Okay. So we will not check it, right? So what we have done till now, we have seen that we got one character which is A, and we saw what is the last index or what is the last occurrence of this character A. So the last occurrence of this character A was at index number 8. After this, we have also checked all the occurrences of the characters which are present inside my part 1, and all the letters or all the characters which are present inside my part 1, they are only present inside my part 1. Okay, they are not present into the other parts or into the other subparts of my string S, right? It means that this is one valid part. Okay, so now I need to store the length of this particular part 1. And how I can calculate the length? It is very easy, right? I just need to do this last minus I plus 1, right? What is this last? Right now, my last variable is pointing at index number 8. So this is 8. What is the value of I? Right now, my I is pointing here at index 0. So the value of I is 0. If 8 minus 0 plus 1, it is equal to 9. This means that the length of this particular subpart is equal to 9, and all the characters which are present inside my part 1, they are only present inside my part 1. Okay, they are not present in the other subparts. So for this particular part of my string, I have make sure that all the characters which are present inside this part 1, they are only present inside this part 1 and they are not present in the other parts or into the other substrings, right? So what I'll do, I will make one vector or one array. Let me just name it as answer, and I will store the length. Okay, so here I have stored the length which is equal to 9, correct? So now what I need to do, now I need to check for the other part of my string. Okay, I have checked until my index number 8. So now I need to check for my index number 9. And how I'll get the value of index 9? It is nothing but last plus 1. Right now my last is pointing at 8. So 8 plus 1 is equal to 9. So now what I'll do, my I pointer will point here at index number 9. So now this is our starting index. Okay. And the character which is present at this index number 9 is D. So now what I'll do, I'll see what is the last index of this character D. So the last index of this character D is here, index number 14, right? So now my last variable will point here at index number 14. Okay. So this particular part of my string, it can be a valid substring, right? It can be a valid substring, but I need to make sure that all the characters which are present inside this particular part of my string, they are only present inside this part and they are not present in the other part of my string. Okay. Now to check this, what I'll do, I will traverse in this particular part of my string. Okay. And I will make sure that all the characters which are present here, they are only present in this part and not outside of this part. Okay. So now I'll have one variable named as j and it will point at index number 10. How I got the index value 10? It is nothing but I plus 1. So right now my j is pointing here at index 10 and the character which is present at index 10 is E. So now I will check the last occurring index of this character E. You can clearly see that the last index or the last occurring index of this character E is at index number 15. Okay. And this particular index number 15 is going out of my part. Okay. My part was from index number 9 up to index number 14. Or if I just explain you, then the value of my last is equal to 14 and the last occurring index of the character E is 15. And this 15 is not lesser than or equal to 14, right? What does it mean? It means that this particular character E is also present. It is also present outside this particular part of my string, right? So now what I need to do, I need to expand my part. Okay. So now what I'll do, now my last will point here at index number 15, right? My last will point here at index number 15. And now the sub part will start from index number 9 and it will go up to index number 15. Okay. So what we have done, we have just increased the length of our part. Okay. We have just increased the length of our substring. Okay. So now I will check for the next character. So now my j will point to the next index, which is index number 11. So again, I will check what is the last index, what is the last occurring index of this character F. So if you see clearly, this F is only present at one index, which is index number 11. So you can say that the last index of this character F is 11 and it is lesser than or equal to my last index, which is 15. It means that this F, it is only present inside this particular part of my string. Okay. It is not present outside of my part. So now I will move to the next index. My j will go to the next index, which is index number 12. Okay. So now the character which is present at index number 12 is E. Okay. So again, I will check what is the last occurring index of this character E. You can clearly see that the last occurring index of this character E is 15. Okay. And this 15 is lesser than or equal to my last variable, right? Because the value of my last is also 15. It means that this E is only present inside this particular part of my string and it is not present outside or it is not present in the other parts of my string. Okay. So I hope this is also clear to you. Now what we will do, we will move to the next index and we will check the same thing. Okay. So now my j will move to the next index, which is index number 13. And the character which is present at index 13 is G. So again, we will do the same thing. We will check what is the last index of this character G. So if you see clearly, the last index or the first index of this character G is 13 itself, right? And this 13 is lesser than or equal to 15, right? What is this 15? This is nothing but our last index. It means that this G, it is only present inside this particular part of my string, right? It is not present outside of this part. It means that this is also valid. So now what we will do, we will move to the next index. So now my j will point here at index number 14, and the character which is present at index 14 is d. So we will check what is the last index of this character d. You can clearly see that the last index of this character is 14 itself, and this 14 is lesser than or equal to my last. The value of my last is 15, right? 14 is lesser than or equal to 15. What does it mean? It means that this character d, it is only present inside this particular part of my string. It is not present outside of this part. Okay, it means that this is also valid. So now what I'll do, now I'll try to move to the next index, right? So now my j will come here at index number 15, but we do not need to check at index 15, right? Because this is the last index of my sub part or of my substring. Okay, so my j will only traverse from I plus 1 up to it is lesser than j, right? So this particular part is also valid substring, because we have ensured that all the characters which are present inside my part 2, they are only present inside my part 2 and they are not present in the other parts or in the other substrings. So now we need to calculate the length of my part 2. And how I can do that? It is very easy. I just need to write last minus I plus 1. So the value of last is 15. The value of I is 9. And if I add just plus 1 into it, then the value will be equal to 7. Okay, so this 7 is our answer. So we need to store this 7 inside our answer vector or inside our answer list. So now we will move to the next part of my string. We have checked for this particular part of my string as well, right? So now I need to start my searching from index number 16. Okay, and how I'll get this index? It is nothing but the last plus 1. So now my variable I will point here at index number 16. Okay, and now we will start our searching from this index number 16. Okay, so now when I'm standing here at index number 16, the character which I found here is h. Okay, so now I will search what is the last occurring index of this character h. So the last occurring index is nothing but 19. So now my last variable will point here at index number 19. What does it mean? It means that this particular letter h or this character h is only present inside this part of my string and it is not present outside this part. Okay, is it a valid string or it is a valid substring? We cannot say that because we need to check for all the characters which are present inside this particular part of my string. Okay, for that we will take help of our variable j. So now I will initialize this variable j as I plus 1. So now my j variable will point at index number 17, correct? And the character which is present at this particular index is I. So I will check what is the last occurrence of this character I. You can clearly see that the last occurrence of this character I is at index number 22. What does it mean? It means that this particular character I is also present outside. It is also present outside this part. Okay, it is present in the other substring as well. So now what I need to do, I need to expand my substring. Okay, so now what I'll do, I'll say that okay, now my substring will start from the same index which is 16, but now it will end at index number 22. So now my last variable will point at index number 22. Now why we have done this? Because now we know that this particular character I, it is only present inside this part of my string and it is not present outside of this part. Okay, so now what we will do, we will move to the next character. Okay, so now I will increment my j. So now my j will come here at index number 18. I will check which character is present here. So the character which is present at index number 18 is j. Again, I will check what is the last occurring index of this character j. So the last occurring index of this character j is index number 24. What does it mean? It means that this j is present outside this part of my string. Okay, so now what I need to do, I need to expand my substring. Okay, so now my substring will start from the same index, which was 16, but now it will end at index number 23. And now my last will point here at index number 23. Okay, so I hope this is also clear to you. Why we have done this? We have done this because now we are very sure that this character J, it is only present inside this particular part of my string. It is only present inside this particular substring. Okay, so now what we will do, we will move to the next index, right? So now my J will point here at index number 19. Again, I will check the same thing. What is the last occurring index of this character H? The last occurring index of this character H is 19 itself. Okay, and this 19 is lesser than or equal to my last variable, right? My last variable is pointing at index 23. Okay, what does it mean? It means that this particular character H, it is only present inside this particular part of my string. Okay, it is not present outside this part. Okay, so now what we will do, we will check the same conditions for the remaining characters. So now my J will go to the next index, which is index number 20. And the character which is present at this particular index is K. Again, I will check what is the last occurring index of this character K. You can clearly see that this particular character K is only present at one index, which is 20. It means that this 20 in itself is the first and last occurring index for this character K. What does it mean? It means that our K, our character K, it is only present inside this particular part of my string and it is not present outside this part. Okay, so now we will check the same conditions for the remaining characters. So now my J will point to the next index, which is index number 21. And the character which is present at index number 21 is L, right? Here you can clearly see that this L is only present at one index, which is 21. It means that the starting index and the last occurring index of this character L is 21 itself. And this 21 is lesser than our last variable. Okay, it is lesser than or equal to our last variable. My last variable is pointing at index number 23. So now I will check the same conditions for the remaining characters which are present inside this part of my string. So now my variable J will move to the next index, which is index number 22. And the character which is present at index number 22 is I. I will check what is the last occurring index of this character I. So the last occurring index of this character I is 22. And this 22 is lesser than my last variable. What is the value of this last variable? It is 23. What does it mean? It means that this character I is only present inside this particular part of my string and it is not present in the other parts. It is not present in the other parts. Okay. So now if I try to move to the next index, then my next index will be 23. Okay. My J is pointing here at index number 23 and it is equal to my last variable. Now, why I do not need to check for this last index? Because I know that it is the last index of my substring. Okay. And all the characters which are present inside this particular substring, they are only present inside this substring. Okay. So I do not need to check for this last index, because this last index is a last occurring index of any character. Okay. It is the last occurring index of this character number J. Okay. So we not need to explicitly check for our last index. So this was our approach. Again, we need to compute the length of this particular part. And how we can calculate the length? It is very simple. We just need to write last minus I plus 1. My last is equal to 23. My I is equal to 16. And if I add 1 into it, I will get 8. I just need to store this 8 inside my answer vector. Okay. So I will store it here. And again, I will try to continue my iteration. Okay. So once we have found a valid part, what was our next step? Our next step was to continue our search from index last plus 1. Okay. So now my variable I will point at index number last plus 1. So now my variable I will point here. Okay. My variable I will point here. But we know that this is not a valid index, right? What does it mean? We have came out of bound. So now we will stop our searching, or we will stop our iteration, right? So this was the whole approach which we are going to use in order to solve this problem. So I hope that the intuition and the approach is clear to you. So now we will think of how we can code this approach. So when my eye was pointing here at index number 0, what I did, I just tried to search what is the last occurring index of this character A. And I found that the last occurring index of this character A is 8. So inside my code, how I will figure out this, that what is the last occurring index of any character. So for this thing, what we can do, we can use a map data structure, or more specifically, we can use one unordered map data structure. Why we are using one unordered map? Because the average time complexity of insertion or deletion of an unordered map is O of 1, or you can say that constant time. Therefore, we will use unordered map. And how this unordered map will work? So see, inside our unordered map, we will have two values. The very first one is the character, and the second one will be the last index. Okay, and how I will compute the last index of any character? What I'll do, I will run a normal for loop. Okay, and this for loop will run from index number 0 up to it is lesser than index number n. Okay, so if I'm standing here at index number 0, what I'll do, I will enter this character A inside my map and the index. So the index is 0. So I will store this 0 as well inside my map. So now we will move to the next index. So my eye will point here at index number 1, and the character which is present at this particular index is B. What I'll do, I will put this B inside my map and the index. So the index is 1. So for this particular B, I will say that the last index which I have seen so far inside my string for this character B is 1, right? And now we will move to the next index, right? So now I will point here at index number 2, and we will see which character is present here. So the character is A, right? And this A is also present inside my map. So now what I'll do, I will just increase, or I will just update the last index. Right now the index is equal to 2. So now instead of 0, I will write 2 here. Okay, I will write 2 here. And again, I will move to the next index, which is index number 3. The character which is present here at index number 3 is B. And this B is already present inside my map. So now what I'll do, I will just normally update my last index, right? So now my last index will be equal to 3. How I got the value equal to 3? Because right now my I variable is pointing here at index number 3. Okay. So similarly, we will move to the next index. So now my I will point here at index number 4. At this particular index, at index number 4, the character which is present at index number 4 is C. I will check, is this C is present inside my map? So the answer is no. So what I'll do, I will enter this C and the index. So what is the index? Index is 4. So I will write 4 here, right? What does it mean? It means that up to this particular index, right? Up to this particular index, the last index of C, or the last occurring index of C was 4. Okay. So now we will continue our searching and we will move to the next index. So now my eye will point here at index number 5, and the character which is present at index number 5 is B. So now I can clearly see that this B is present inside my map. So what I'll do, I'll just normally update my index. So the current index is 5. Okay. So now I will just update the index, and now my index will be 5, right? And this 5 is indeed the last occurring index for this character B, right? So we will continue this particular process for all the indexes which are present inside my string, and then we will compute our map, and inside our map at the end, we will indeed have the last occurring index of each and every character. So now let's fastly code the approach which we have just discussed. So I will need one vector of integer type. Let me name it as answer. Okay. So this is our answer vector where we will store all the lengths, and at the end we will return this answer vector. Apart from this, I also need one unordered map. Okay. And this unordered map will store all the characters and their last occurring indexes. So indexes are nothing but integer values. Therefore, here I am writing int. And let me name this map as MP. So now I need to store all the characters and their last occurring indexes inside this map. For that, what I can do is I can run a for loop. Here I will start from 0 and it will go up to it is lesser than n. Okay, and what is this n? This n is nothing but the size of our string s. Inside this for loop, I can directly write mp of s of I is equal to I. Okay, so after coming out from this particular for loop, all the characters and their respective last occurring indexes will be stored inside our map mp. Okay, after doing this, we need to iterate into our string s. Okay, for that, let's say I'm having one variable named as I. It is initialized with a value 0. So I will run one while loop while my I is lesser than n. Okay, so inside this while loop, very firstly, I need to calculate the value of the last occurring indexes of the character which is present at index number I. Okay, for that, here I can write that int last is equal to mp of s of I. Okay, apart from this, what I can do is I can also calculate the length of my substring. Okay, for that, here I can directly write that int len is equal to last minus I plus 1. Right, after doing this, what I need to do, I need to check that all the characters which are between the index I and last. Okay, all the characters which are between the index I and last, I need to check their last occurring index as well. Okay, for that, what I can do is here I will write one for loop. Here my j will start from index number I plus 1 and it will go up to it is lesser than last. Okay, so I need to check that what is the last occurring index of the character which is present at this particular index j. For that, here I can write int temp last, it will be equal to mp of s of j. Okay, and here I will check that if this temp last is lesser than or equal to my last, then I do not need to do anything. Okay, but if this temp last is greater than my last, then I need to increase the length of my substring. Okay, for that, what I will do is I will update the value of my last variable. Okay, so now my last variable will extend up to this temp last index. Okay, and again I will update my length. So now my length will be equal to last minus I plus 1. Okay, and here this particular for loop will get end. Now after coming out from this for loop, the length variable will store the length of my substring. Okay, which is a valid substring. So what I'll do, inside my answer variable, I will push my length. Okay, so here I will write answer dot push back len, and now I need to move to the next index, and my next index will be nothing but last plus 1. So I will store this value inside I. Okay, and here my while loop will get ended, and at the end I just need to return my answer. So this is our code. I hope it is clear to you. So now if we talk about the time and space complexity, so very firstly, let's talk about the space complexity. Okay, so what we are using one map, and inside this map we are storing all the characters and their last occurring indexes. So how many number of characters do we have? It is nothing but equal to n. Therefore the size of this mp will be equal to O of n. Apart from this map, we are using one vector named as answer. So what will be the maximum size of this answer? At max, it can be equal to O of n. Okay, so here the space complexity will be O of n plus O of n. So we can say that the approximate space complexity will be equal to O of n. So now if we talk about the time complexity, then here we are using one for loop. Okay, and it is running from I is equal to 0 up to it is lesser than n. So in total, this particular for loop will consume O of n time complexity. Apart from this, what we are doing, we are using one while loop while my I is lesser than n. And inside this while loop, we are again using one for loop. Okay, but one thing which you need to remember is, with the help of this while loop and this for loop, we are iterating inside our string s. But we are going to each and every index of our string s exactly one time. Okay, therefore the time complexity from this while loop and this for loop together will be equal to O of n. Okay, I hope you have understood this. So here I can write that the time complexity will be plus O of n. So now you can say that the approximate time complexity is equal to O of n. So now I hope that the code is clear to you, intuition is clear to you, the time and space complexities are clear to you. So now let's directly go on LeetCode and code it up. So now we are here on LeetCode. So let's start coding. Very firstly, I would need the length of my string s. Okay. Apart from that, I need one vector where I can store my lengths. Okay. So let me name it as answer. And at the end, I will return this answer. Okay. Apart from this, I also need one unordered map. And inside this unordered map, I'll store the characters and the last occurring indexes. Let me name it as MP. Now, with the help of one for loop, I can store all the characters and their last occurring indexes inside my map. So inside this for loop, I just need to write MP of s of I equal to I. Okay. After doing this, I need to iterate inside my string s. Okay. For that, I can use one variable I, and it will be initialized with a value 0. So here I need to write one while loop while this I is lesser than n. Okay. And inside this while loop, firstly, I need to calculate the last variable. Okay. So this last variable will be nothing but the last occurring index of the character which is present at index number I. Okay. Apart from this, I also need to calculate my length. So my length will be last minus I plus 1. Okay. Now I again need to check that all the characters which are between the index I and index last are only present inside that particular part of string or not. For that, I can again use one for loop. Here I will write int j is equal to I plus 1. J is lesser than last, and here I will do j plus plus. So now I need to check the last occurring indexes of the characters which are present at index number j. For that, here I can write int temp last is equal to MP of s of j, right? And if this temp last is greater than my last, then I need to update my variable last. So my last will be equal to temp last, and here I also need to update my length. So my len variable, it will be equal to last minus I plus 1. After coming out from this for loop, my length variable will get updated. Okay. So I need to store the length inside my answer vector. So here I will write answer dot push back len. Okay. And now I need to move to the next index. So my next index will be last plus 1. And I will store this value last plus 1 inside my index I. Okay. So this is our code. I hope the code is clear to you. So now let me run this. So here we are having one compilation error at the line number 19. It is saying that the spelling of temp last is wrong. Okay. So here it will be equal to temp LAST. Okay. And I think now it should run fine. So here you can clearly see that the two sample test cases are running fine. So let me just submit this. So here you can clearly see that this particular solution is accepted. So this was all for this video. I hope this video was helpful to you. If it was, then make sure that you like to this video. Don't forget to drop a comment. And if you want this type of content regularly, then make sure that you subscribe to this channel as well. We will meet again tomorrow with a new question.